Let's look at some graphs of exponential functions. So we have this one, y equals 2 to the x. There's a couple ways you can graph it. You can just put it in y equals in your graphing calculator and get some points. I'm going to make a little table here. If x were 0, anything to the 0 power is 1, so that's going to give me the point 0, 1. If x was 1, 2 to the 1 power is 2. If x was 2, 2 to the second power is 4. Whoops, I graphed that wrong, didn't I? 0, 1, 1, 2, 2, 4. Let's go ahead and do 3 just to see what happens. 2 to the third power is 8. So this one's going to be way up here. Now, we're seeing that this is shooting up quickly, but we don't really know what it's doing over here. So let's look and see what if x were negative. Well, 2 to the negative 1 is 1/2, because remember that when you put something to a negative exponent, you can make it positive by putting it in a denominator. So negative 1, 1/2. If we went to negative 2, we would have 1/4. So if you do this, you're going to see that this is going to keep getting smaller and smaller and smaller, but it will never be 0. There's never an x value that you can raise 2 to and make it 0. It'll never ever be 0. So this graph looks like this. It's exponential growth because this number raised to the exponent is bigger than 1. It starts small and it shoots up. You can see that there's no boundary on the left, no boundary on the right. Therefore, your domain is all real numbers. The domain of every exponential function in Algebra 1 is like the domain of every quadratic function in Algebra 1. It's all real numbers. The range is your y. You can see that y never goes down here to the negatives. It always stays above this x-axis. Now remember how I said it never touches it. So it never hits 0. It's always greater than 0. It can't be greater than or equal to because it's never going to touch it. So y is always greater than 0. Where's your y-intercept? Well, it's right there where x is 0. And then we have this new fun word called an asymptote. An asymptote is a horizontal, we have a horizontal asymptote in Algebra 1, and it's an imaginary line that this graph hovers over, gets closer and closer to, but never touches. So this horizontal line is y equals 0. It's going to be the same as your range. It's going to match your range because your range is going to be this number that it never touches, but it hovers over. So let's look at a decay. This one has a factor less than 1, a fraction between 0 and 1, so it's decay. Let's make a little table. Anything to the 0 power is 1, but 1 times 8 is 8, so we're going to get 8 here. And then 1/2 to the 1 power is 1/2. Half of 8 is 4. 1/2 squared is 1/4. A fourth of 8 is 2. So you're going to see here 1, 2, 3, 4, 5, 6, 7, 8. We have a y-intercept of 0, 8. Then we have 1, 4, 2, 2. Let's see what it is at 3. 1/2 to the third power is going to be 1/8. When you multiply that, you're going to get 1. So this is decay. I could keep this going, but you get the point that it's going to get closer and closer to 0, but it's never going to touch it. So we have the same thing. We have a domain of all real numbers. We have a range of y greater than 0. We have a horizontal asymptote of y equals 0 because it's going to get closer and closer to this line here but never touch it. It's exponential decay though because it starts really big, goes down really fast, and then just hovers this way and gets closer and closer and never touches it. So this is how you graph and the functions, the features of a graph of an exponential function with this new fun word called an asymptote.